Hello, myself Divya. We are going to give a demo on Cisco Packet Tracer. Now I will show how to install Cisco Packet Tracer 6.1. We have already downloaded it. Meanwhile, I will explain about Cisco Packet Tracer. Cisco Packet Tracer is a powerful network simulator to get the real-time scenario. Packet Tracer is an interactive tool for learning basic operations of various network devices at the data link and network layer of OSI model. We can observe the behavior of data frames and packets as they traverse through routers, switches, and other devices. It can visualize and learn the concept of network technologies. The configuration of Cisco Packet Tracer is, it works on Windows. The stable release of Cisco Packet Tracer is 6.1. Available for free of cost, and installation is very easy. The application of Cisco Packet Tracer in OSI model are in application layer it supports FTP, SMTP, HTTP, POP3 and so on. And in transport layer it supports TCP and UDP. At network layer it supports BGP and ICMP. The kind of topologies required to build network are router, repeater, cloud, hub, switch, wireless access point, bridge, PC. The type of interfaces can be selected to interconnect hardware devices are Ethernet, Fast Ethernet, Gigabit Ethernet, serial modem, wireless. Cisco Packet Tracer 6.1 is a utility that can be used by students to train themselves in CCNA and CCNP by permitting them to create networks by utilizing unlimited number of devices. By using this application, you don't need to buy Cisco troubleshooting. Cisco Packet Tracer 6.1 has different capabilities of visualization, authorization and collaboration, and provides facilities for learning some complicated technological concepts. Features of Cisco Packet Tracer 6.1 are it can be used for CCNA and CCNP training purposes. It can create networks by utilizing unlimited number of devices. A new service tab introduced. NetFlow collector and AAA accounting have been included as new server application. IPv4 and IPv6 have been shifted as desktop application. And it can develop skills like decision making and critical thinking. This is called the menu toolbar, and this is the space. And this is device type selection, where you can select switches, routers, hubs, wireless devices and connections, and also end devices, securities, wireless RAM emulation, custom made devices, and multi-user connections. This is device specific selection box. Where you can select the routers, various routers, and this is status box. That is common. This is common toolbar. where we can select the PDUs to drop the messages from one system to another system. We have two types of modes. Real mode and simulation mode. In real mode, we can see the connections of devices when it forms a network, and in simulation, we can execute the network. Now coming to the device type selection, we have various devices like routers, switches. Routers is a piece of network hardware that connects a local network to the internet. Most of the routers are more properly called residential gateways. And a router is more sophisticated network device than either a switch or a hub. And a switch, a network switch, is a small network device that joins multiple computers together with one branch. Ethernet moves forward packets to the destination. Networks, routers, switches, and hubs are all common components of wired Ethernet networks. Routers forward network data more intelligently. Each features a number of physical pathways on the front or back of the unit that provide the connection of pathways for these computers, a connection for electric power, and number of LED lights to display devices status. Now we'll give an example of how Cisco Packet works. We'll connect two routers and we'll connect two systems using routers and show how the message is passed between them.
Hi, myself Varsha. I'm going to show you the working process of Cisco Packet Tracer. Okay, now I am going to show the example of two end devices, using two end devices and one router, which are connected through the connections. Taking the two end devices as generic PC0 and PC1, take a router as 1841 router, connect it to the connections through copper crossover connections. From PC0, connect as fast Ethernet 0 to router fast Ethernet 0/0. Same for PC1. Now click on the router. We will get a window displayed. Click on the CLI, then the configuration dialog box will appear. It will ask for continue with configuration dialog. Yes or no? Just type yes. No. Then enter it. Enter enable to enter the privilege exact mode. After entering into the privilege exact mode, we have to configure the modes. Config T is nothing but it is a global configuration. Next, enter the host name for giving the name to the routers. Now enter enable secret class for setting an encrypted password. For privilege exact mode, we can give enable secret class or enable secret Cisco directly. Now line con 0, it means it is a console line. We are entering into a console line. Then enter the password as Cisco, which we are giving for the class. Then log in through the password and exit from that interface. Login will enable password prompting, where exit will return to the global configuration mode. Now type line vty 0 space 4 for configuring the password for virtual terminal line. Right now password as Cisco for the virtual terminal line. Then login for the password requirements. Login for the password requirements. Exit from the virtual terminal configurations. Then if we want to configure fast Ethernet interfaces, enter interface name. The interface name as fast Ethernet. Fast Ethernet 0/0. Now enter the IP address to set the interfaces of the IP address into a subnet mask. IP address 192.168.1.1 space 255.255.255.0. For later reference of the description of the interface, we have to enter description routers 0 space fast Ethernet 0/0. Now enter the command no shutdown to start the interface. Exit to come out from the interface. Now repeat the configuration for the fast Ethernet 0/1 by using the interface and the interface name as fast Ethernet 0/1. Giving the IP address for the interface 192.168.1.2.1 space 255.255.255.0. Now for the description for the later reference of fast Ethernet 0/1, write description router 0 space fast Ethernet 0/1. Now type the command no shutdown to start the interface. Exit from the interface configuration mode. Then type exit to come out from the global configuration mode. If we want to display the current configurations, then type show running dash config to see all the configurations we have did. Here are the configurations we have did for interface fast Ethernet 0/1 and interface fast Ethernet 0/0 and the virtual terminal LAN. This is a console connection. Now, if you want to save the configuration to NVRAM, write copy running dash config startup dash config. Now the configuration is built to the destination. Then close the window of router 0. By now we will see the green dots appearing at the ends of the routers and the PCs. It indicates that they are connected. The wires are connected. Now to configure the PC, click on PC 0. PC 0. Go to desktop. Then click on IP configurations, where IP configuration should be always static. Now type the IP address as 192.168.1.2, where the subnet marks will be automatically appear 255.255.255.0. The default gateway would be 192.168.1.1. By setting the PC 0 IP configuration, close the window of PC 0. Click on PC 1. Go to desktop icon. Click on IP configurations. It should be static. Then set the IP address as 192.168.2.2. The subnet mask will be automatically appear 255.255.255.0. Now type the default gateway as 192.168.2.1. By setting the PC 1's IP configuration, close the PC 1's window. Now let's trap from PC 0 to PC 1. Just go to PC 0. PC 0, go to IP configurations. Go to command prompt, type the IP config to get the IP address. IP config to get the IP address, subnet marks and default gateway which we have set for PC0. Now to ping PC0 to PC1, type ping 192.168.2.2 to ping PC1. At the first time, we may get a request timed out. Try it once again. So, we are getting the replies from the PC1 and the average, minimum and maximum packets which are sent, received and lost. Close the window of PC0. Let's see the simulation. Right now we were in real-time mode, which we have done the connections of the devices and the routers. Now we will go for the simulation mode, which is at the right hand side corner. Click on the back side of the real-time mode, that is simulation mode. Go to edit filters where all the checkboxes are punched. Now come back to show all none. The checkboxes are now empty. Just click on ICMP. Then go to first envelope. Click first yellow envelope which switches from source to the destination, that is from PC0 to PC1 for PC1. The envelope is nothing but an PDU, protocol data unit. Now click on auto capture or play to begin the ping simulation. Now we observe here the PDU travels to the router 0 through the router 0 from PC0 to the PC1 and then back to the PC0, which gets the acknowledgement. Here the message is correctly successfully got over. Okay, in the status toolbox we will see where the source is the PC0, destination is the PC1 and the type which we are using is the Internet Control Message Protocol, which travels the message from PC0 to the PC1 through a router and gets an acknowledgement to the PC0. Thus it is a successful as shown in the status. Now the events which we are going to happen through the message while traveling are shown in the event list. Let's take another example. Just go to File, New, take N devices 4 which are generic PC0, PC1 and PC2. Now take a laptop generic as PC, laptop 0. Take the switches As we saw the first example with the routers, now we will see the example with the switches. That is 3 switches. Take 3 switches, that is 2960 for connecting the 4 end devices and 2960 for connecting PC1 and 2960 for connecting another laptop. Now the connect it through the connections as copper straight over connection. From PC0 connect it through fast Ethernet 0 to switch fast Ethernet 0/1. From PC1 connect it through fast Ethernet 0 through to fast Ethernet 0/2. From PC2 connect it through fast Ethernet 0 to fast Ethernet 0/3. From laptop connect it through fast Ethernet 0 to switch fast Ethernet 0/4. Now these are connected. Now connect through the console wire. From PC0 connect it through the switch as RS32 to the console. Click as console. Now from PC1 take a console as RS32 to the switch 1 for console. The same wise for the laptop to the switch 2, the connection. Now set the IP address as 192.168.1.1 for PC0. For PC1 set as 192.168.1.2. For PC2 set the IP address as 192.168.1.3. For laptop set the IP address as 192.168.1.4. Now we have set the IP address. Just click on PC0 to see the IP configurations. Set the IP configurations as 192.168.1.1. Some networks will be automatically, the default gateway will be 192.168.2.1. Close the PC0's configuration. Now do it same for PC1, PC2 and laptop. Now we are completed with the IP configuration of all the PCs and the laptop. The green dots indicate that they are connected. The devices are connected with each other through the connections. Go to the simulation mode. Check for the go to edit filters. If the all checkboxes are punched, then go to show all none. The all checkboxes will be empty. Click on ICMP and DHCP. Now at the right hand side there will be a simple PDO. Click on the simple PDO. Select the source, that is PC0, and destination as laptop. Now you will click on the auto capture or play. You will see the process, how the message is transferring from PC0 to laptop. Through and switch. Just in ICMP, it sends the message to PC to switch and switch to laptop. From laptop, it gets an acknowledgement and sends to switch 0, and then it gets an acknowledgement to the PC 0. Now we will see with another protocol, that is address resolution protocol. Address resolution protocol In address resolution protocol, the packets are sent to all the devices and it checks the packet is sent to the correct device or not. If it doesn't, then it shows the wrong or cross mark on that packet, and again it sends an acknowledgement to a particular device which shows a correct mark, that is right mark, which is successful. In the status, we will see the correct mark which is shown as successful from source to the destination, and in the event list we will see what are the events going on happen. Lastly, thank you.